Every now and then, an idea takes form that changes everything. It revolutionizes the way we see and understand the world around us. I believe that just such an idea took form in the medieval Islamic world. It's the idea that everything, from the stars above to the workings of our own bodies, is not arbitrary or whimsical, but subject to certain systematic rules. And what's more, that we humans can work out what those rules might be. And then we can refine and test our theories through observation and experiment. In other words, it's the idea we now call the scientific method. For me, the story of the scientific renaissance that took place in the medieval Islamic world is a personal one. This is my cousin Samir's house in the Iranian capital, Tehran. I haven't seen some of the relatives on my father's side of the family in over 30 years. This is my not so tall but very beautiful Auntie Anisa. The Al-Khaleeli family is originally from the city of Najaf in Iraq, south of Baghdad. In fact, I grew up in Iraq. But when Saddam Hussein came to power, the family split. Many of the Al-Khaleelis fled here to Iran. As my mother's English, I came to Britain with my parents. There, I pursued my passion for science, and am now a professor of physics at the University of Surrey. But now, I find that my own scientific work and my Arabic and Islamic heritage are intertwined. On my journey through the Middle East, I discovered that an astonishing leap in scientific knowledge took place here 1,000 years ago, under a powerful and flourishing Islamic empire.
Wealthy, powerful, successful cultures will produce enormous advances in understanding and in technique. And that's just what we find in Islam, in Baghdad, under a series of successful, powerful, wealthy, and self-confident Islamic regimes.
Over 1,000 years ago, the Islamic Empire was the largest in the world. It governed an estimated 60 million people. That was over 30% of the world's population. I found an archaeological fragment of this glorious past in a suburb of Tehran, not far from my cousin's house. These ancient walls, tucked behind a back street on the outskirts of southern Tehran, are literally all that remain of the ancient city of Ray, the city that the great Persian geographer al-Muqaddasi described as one of the glories of Islam. Of course, Ray was just one of a number of cities that flourished under early Islamic rule. From Baghdad, its capital, the empire spread across thousands of miles, from North Africa through to Central Asia. Cities like Al-Askar, Basra, Merv, Gurganj, Bukhara, each powerful and thriving cities. Each would have been rich in trade, alive with culture. Each would have had its own libraries, its own academies. These were powerhouses of the new science. This really was a golden age.
Think of that span of land. This is larger than any empire human civilization had ever known. Within that span of land, you can plug in the Roman Empire and it will fill just maybe, what, 1/3 of it, 1/2 of it, or something like that.
Reminders of this great Islamic empire are everywhere in the Arab world today. This football match in the Syrian capital Damascus is being played at the Abbasid Stadium. That's the name of the family who ruled the Islamic Empire from 750 to 1258 AD.
هذول اجوا بعد عهد الأموي وعملوا حضارات بناء.
This large territory allowed them to raise enormous tax revenues to fund a search for knowledge and scholarship, which became known as the translation movement. They sent scholars around the known world to gather up great books and have them translated into Arabic. It's a legacy that's still alive in the minds of most modern Arabs.
الجماعة اهتموا بالفكر بالفلك وقدموا يعني طوروا تقويم الشهر كمان وعربوا الكتب اليونانية واهتموا بالعلم كثير بالطب والهندسة وكل
For medieval Islamic leaders, scientific knowledge was crucial to successfully running a vast empire.
They did have a big and sophisticated governmental administration, and obviously that needed knowledge. If you wanted to be an administrator and you had to assess taxes, you needed to know about mathematics. It also wants to be able to build monumental buildings. That requires the knowledge of architecture and, again, mathematical skills to construct fine buildings safely. Medicine, just to keep the elite happy and healthy. And those are the areas of knowledge which are first translated from other languages into Arabic.
The legacy of the medieval Islamic empire is scattered across a vast region. There's architectural masterpieces like the Umayyad Mosque in Damascus, the Jami' Mosque in Isfahan, and Al-Azhar University Mosque in Cairo. And then there are many ruins that still hint at past glories, like this, a crumbling 8th century palace deep in the Syrian desert. And this, a huge Muslim palace called Medinat al-Zahra, currently being excavated in southern Spain. These are the impressive ruins of Medinat al-Zahra, the fantastic palace city built outside Cordoba in the 9th century by Abdurrahman III, who was the greatest of all the Andalusian caliphs. At the time that it was ruined, Cordoba was in fact the largest and most important city in Europe, a rival to Baghdad in the east for a center for Islamic scholarship and science. And as I traveled, I saw how science, especially numerical record keeping and measurement, was crucial to dealing with the challenges of running a vast empire. This is the mighty River Nile as it flows through the Egyptian capital, Cairo. Since antiquity, its unpredictable floods have determined the fate of Egypt's people, bringing years of lean and plenty. By the 8th century, Cairo was part of the Islamic Empire, and the new rulers took the first step to understanding this mighty river in a scientific way. They built a device to measure it.
Amazing structure, right?
Dr. Nader al-Bizri of the Institute of Ismaili Studies is showing me the Nilometer. It's basically a huge colonnade that was built in a chamber connected by tunnels to the river. As the water rose or fell, its height could be read from the central column.
The central colonnade here is ultimately a measuring instrument. It is very precise. It's almost 1 inch between a marking and another.
Presumably they need to know seasonal variations in the height.
And to try to have some sort of record so that they could measure against certain years, where a year was known for a high level of flood versus another year known for its drought. Then they might perhaps take some precautions.
Yes. The data collected from the Nilometer did have one practical use. By creating an objective record of the river's behavior, It allowed the rulers of the time to calculate how much tax to levy on Egypt's farmers. But whatever its uses, what I love about the Nilometer is how it shows that to understand the world, you have to build devices to measure it.
If you think very hard, it's never obvious that measurement can make sense of the world around us.